15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again, thank you for joining us on Space Nuts. It's a show all about astronomy and space science. My name is Andrew Dunkley. I am your host. And today we're going to celebrate a birthday, the Parkes Radio Telescope in New South Wales. It's only 120 kilometres down the road from where I am. It has just turned 60 years old, so that's extraordinary and still going strong. We will also be looking at, speaking of telescopes, the benefits of putting a telescope past Saturn. Now, I know we talk about the James Webb Telescope and where it's going to go, but there are now thoughts that we should probably put one out past Saturn, and Fred will explain why. Apparently, there are some real benefits into doing that. And audience questions today from Jim, who wants to challenge Einstein. Also, Damien, who wants to talk about something completely different today, dark matter. And Robert has got a question about Mercury, which I find fascinating, but even more fascinating was his second question about what we need to look for and how we might detect the light being produced by aliens on other planets. We produce light, which travels out into space. So how would we detect the light of other civilizations, like from their streets and houses and sporting fields and the like? That's a great question. So we'll be tackling all of that today on Space Nuts. And joining me as always is astronomer at large, Professor Fred Watson, the space nut, space warper himself. Hello, Fred.
Hi, Andrew. Thank you. Yes, a space warper. I like that.
Yes.
I wonder where that idea came from.
I don't know. How's the book going, by the way? There it is.
Well, I don't know. I assume somebody's buying a copy. It went into the bookshops on Monday this week, 3 days ago. 2 days ago. It has had some nice responses from the media. I've done a lot of radio interviews and a couple of things like that, which include, I had a nice chat with Ian Connellan, who is the editor-in-chief, I think, of Cosmos magazine, which is one of the leading science magazines here in Australia, and he tweeted the recording this morning. I think it's basically a video conversation, mainly because I could see myself on the tweet. But he's picked up on a story I told him about when I was a youngster, trying to observe the sky with actually a borrowed telescope at that time. It belonged to my history teacher at school. He was very generous to lend it to me. A telescope about 4 feet long, made of brass, ancient machine. I had it in the back garden, and a large policeman turned up and said, hello, 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 what's going on here then?
What's all this then?
And he thought somebody had phoned the police to say there was a kid playing around with a bazooka in the backyard. So anyway, that's turned up in this record. I'd forgotten I mentioned that actually. Turned up in this recording, Cosmos.
That is funny. Oh dear, oh dear. As long as you weren't making rocket engines in the garage and fueling them with motor mower petrol.
Yeah, I did the rocket engines too, but fortunately nobody turned up after that.
Dear. It's funny. Well, from all the comments I've seen in the Twitter sphere and on Facebook through the podcast group, people are pretty excited about your book, Fred. So
that's lovely to hear. Thank you, Andrew. Yeah. That's the first report I've had of anybody other than the media who's vaguely interested in it.
Yeah, quite a few people busting a gut to get a hold of it. So I think you'll be fine. You might get enough for a chicken dinner or something. Now. That's all I get. Let's talk about the Parkes Radio Telescope, which has just celebrated its 60th birthday, commissioned on the 31st of October, 1961. And the story behind this telescope is intriguing. I see it maybe a couple of times a year driving past where it's located just north of Parkes in central west New South Wales. And it is a sight to behold. You just can't miss it. It's just, it's so prominent on the landscape there, and it's still in the middle of sheep paddocks or wheat paddocks, is it?
Yeah, no, it's sheep paddocks.
Sheep
Or it was
paddocks.
last time I was there. Yeah, so you're absolutely right. I think the Parkes dish, for all optical visible light telescopes, are closest to my heart. I think the Parkes dish is one of the most beautiful telescopes in the world because it's set in the Gubang Valley, and when you see it from the road, you see this background of hills behind it, and the pasture lands that it stands in, and it's unmissable, exactly as you've said. It's just a few kilometres from the main highway, and I'm surprised there aren't more accidents in that
Yeah,
area.
mate, I was about to say that. It's quite a distraction.
It's a distraction, yeah. You've got to look at it and see where it's pointing, things of that sort. But yes, it is 60 years old, or it was on Sunday. It was launched on Halloween Day in 1961. Yes, if any of our listeners feel like checking out the conversation, which is an online news feed. Actually, it's run by experts who are also journalists. That's the way it's supposed to be. But there is a piece there by John Sarkisian, who's I think he's telescope operations manager. He's an operations scientist. I know John very well. He's a great guy, a great science communicator, has been based at Parkes for certainly as long as I've known him. Instrumental, incidentally, in running the David Malin Awards, which I don't know whether you know about. I'm sure we've talked about them before. David Malin, another good friend, but also the man who effectively put colour imagery into astronomy back in the 1970s. And nowadays, amateur astronomers are doing work that rivals what David did with the Anglo-Australian telescope back then. John and he kicked off the David Malin Awards for amateur astronomers, which I think has been running for 13 or 14 years now. It might not be quite that long.
Geez, I might have to have a crack at that.
You should, with your new telescope when you've got it. Yeah,
I'm getting one.
And your iPhone. Anyway, that's off the topic. We can talk about that later because your telescope's something I'm very envious of, even though you haven't got it yet. The Parkes dish, though, was really a big step in absolutely cementing Australia's place as a world-class nation in terms of radio astronomy, and indeed that. But by then, radio astronomy in Australia had been going for 15 or 16 years. It was a fairly mature science because it kicked off with World War II radar equipment on the coast near Sydney. In fact, one of the northern suburbs of Sydney, not very far actually from where I'm sitting now. The Coleroy Plateau, they had a radar dish there that basically was used to pick up the radio signals from the sun, which is the brightest radio object in the sky, and try and figure out what was going on. Nobody knew what this radio stuff was all about, where it was coming from. And that was also, there were a number of people who later became legendary in the world of radio astronomy, including Ruby Payne Scott, who was the world's first radio astronomer. She worked for what was then the Radio Physics Laboratory, the Council for Scientific and Industrial Research, CSIR, which is the forerunner of today's CSIRO. And they had another one at Dover Heights, which is in a different part of Sydney. So fantastic stuff. Then the radio telescope was built. It was, I think, the biggest in the world at the time. The only other one competing, and I can't remember the diameter of the other one. Parkes is 64 metres in diameter, but 1957 saw the building of the Jodrell Bank radio telescope in a place not very far from Manchester in the north of England by another individual who became a legend, Sir Bernard Lovell. He was very much a name that was always in the media when I was growing up. So the between them, the Parkes dish and the Jodrell Bank dish really revolutionised radio astronomy in those early years.
Jodrell Bank is bigger; it's 76 metres.
Yeah, okay, that sounds right. But Parkes can lay a claim to being one of the most advanced radio telescopes in the world. It was using receivers that that I think were probably better than what they had in Britain. I'm not sure. Once again, these were all X-radar receivers. Sorry, go ahead, Andrew.
No. I just said maybe you're right that it technologically was probably the best telescope, radio telescope in the world at the time. But it's kept up, which is good.
Yeah, it has. And today it's got state-of-the-art cryogenic PAFs. PAF is a phased array feed. These are basically image sensors for radio telescopes, which have been pioneered here in Australia by CSIRO. An extraordinary story. One of the other things I like about the Parkes story is, and this is fairly well known, including the diagram that's in John's article, one of the engineers who looked at the issue of building this giant radio dish and how you might actually engineer it so it wasn't going to fall over or blow over with the wind. It was Barnes Wallis, who was the famous engineer who devised the bouncing bombs that were used in the Dam Busters raid in 1940, whatever it was, 42 or thereabouts. Barnes Wallis, very well known and very highly respected engineer. He also had a shot at designing the Parkes dish. His design was not the one that was eventually chosen, but there's a picture of it in John's article.
That's amazing. That is incredible. I suppose it's achieved a lot in 60 years, but I suppose most Australians connect the Parkes Radio Telescope not only with the movie called The Dish, which is a funny Australian film if you want to watch it, but the serious side of it was that the dish was really instrumental in getting some of that imagery and audio from the Apollo 11 mission, and those images went around the world. So it was a key player in that particular event.
Indeed, it was, along with, and it's always worth mentioning this, along with the Tidbinbilla antenna as well, which is in Canberra, and that they shared the glory with all that. They tend to be the forgotten ones, but it's very interesting. I know, I think he was the chief engineer there at the time, Mike Dinn, his name is, if I remember rightly. And it turns out, Mike and I have spoken a number of times. He's about 10 years older than me, but it turns out that he and I used to get the same bus to school in Yorkshire. So he was probably a bit ahead of me, but it was the same bus that we used to get.
Yeah.
No,
the telescope's price tag back then was $1.4 million.
Exactly. Well, they say that's... Sorry, go ahead.
Yeah, well, that's $25.5 million in today's money.
Which is incredibly cheap.
Yes.
It was done on a shoestring, even at $25.5 million. That's, in today's terms, that's incredibly cheap, really, for a telescope like that. And given what it's done, what it has achieved, not just in the Apollo issues, but it's also the instrument that first detected fast radio bursts. It's detected all kinds of things. It's detected the non-wow signal that we spoke about a couple of weeks ago, BLC1, the Breakthrough Listen Candidate.
And it's detected people opening the doors of microwave ovens.
Exactly. And in fact, John Sarkisian, who wrote the article, was one of the people who figured out what was going on with that these peritons, as they were called, were actually caused by people opening the microwave when it was still cooking.
Yes, exactly right. And one other thing I like is last year, in keeping with Australia's move towards reconciliation with the Indigenous people of this country, the local Wiradjuri people gave the telescope the name Murrayang, which means Sky World, which I think is lovely.
Yeah, it's a lovely name. I agree with you. It's a delightful name.
Fabulous. So if you're ever in the neighbourhood of Parkes in central New South Wales, make sure you visit the CSIRO facility, the Parkes Radio Telescope. It is worth visiting. I actually haven't been to the site proper. I've driven past it many times, but I went there as a kid when I came out here on holidays to visit my cousins years ago. So I'm long overdue to go back and have another look. And Judy and I keep saying, we've got to go in there one day, but we're always in too much of a rush.
That's
And
right.
it's one of the great failings of people. They live near these incredible things. And I remember when I lived up in Mackay, North Queensland, Fred, and that's the gateway to the Great Barrier Reef, one of the natural wonders of the world. And I remember living there, and of course, Judy and I went out to the reef and visited the islands and, did all sorts of things because, we were there, we could do it. But you speak to people who'd lived there 30 years or 40 years. Oh, yeah, no, never been there. Never been there. And it's a natural thing. And the same thing happens in Dubbo. We've got a world-class zoo here.
You do, that's right.
And people, the locals don't go.
No.
I mean, they just don't go. It's just, we'll get there one day. It's not going anywhere. It seems to just be a natural human trait that people come from all over to visit these things, but the locals don't bother.
Yeah, you should follow the adage, use it or lose it.
Yeah, exactly right.
Sorry, go ahead.
I was just going to say one more little anecdote, which is not astronomy related, but when the zoo was first touted to be built in Dubbo, the locals rebelled, saying, the lions will escape and eat us all.
Hasn't happened
Thankfully,
yet.
They weren't listened to.
No. But just going back to parks, though, Andrew, you really should go if you haven't been for that long, because the visitor centre there is quite spectacular. It's a really nice visitor centre with a very nice cafe attached to it. And that was funded, of course, probably 20 years ago now, but it was funded from proceeds from the movie, from the dish, because the telescope took some sort of license fee, and that went into building the visitor centre, which is fabulous.
Didn't know that.
Yeah.
Well, that's fantastic. Yeah. You used to have a nice visitor centre too, Fred.
At Siding Spring. It's still there. It
survived the fire, did it?
It did survive the fire, yes.
Yeah, I knew. I wasn't sure what survived and what didn't, but
no, it did.
Yeah.
It's opening up slowly in the wake of COVID-19. But it's. I think you can only go at certain times, but it's opening up gradually. Yeah,
that's another place worth visiting. Getting up on top of Siding Spring and the observatory up there. It's truly spectacular. And I really enjoyed that day. We went right to the very top.
Yes.
And it was supposed to be summer, I think, but it felt like about minus 50.
Yeah, it's always windy up there.
Yeah. It felt like you're on top of the world, though. It's incredible. So happy birthday to the Parkes Radio Telescope. And if you ever get to come over here from overseas and visit, don't forget to drop into Dubbo and say hi as well. Love to see you. This is Space Nuts with Andrew Dunkley and Fred Watson. Time to take a little break and tell you about our sponsor, NordPass. Now, don't get this confused with NordVPN, which I've told you about before. NordPass is all about your passwords and your cybersecurity in regard to how to store and control your passwords and, how to limit access to them by people you don't want getting hold of them. NordPass is a really fabulous piece of software that enables you to store all your passwords in one convenient place, easy access, and very, very secure. And it will help you in a great many ways. Now, if you're like me, you have a massive number of passwords for a massive number of reasons. And sometimes you'll try to log on to something or you'll be logged out of something and go, oh, damn, what's my password? And you can't remember. You can look it up easily with NordPass. It's an easy download piece of software, very, very, very easy to use, and it has all sorts of benefits. It will keep an eye on your password health. If they think you're vulnerable, they will warn you. It can do a data breach scan, so you'll know whether or not somebody's trying to get into your stuff. And it's got this brilliant thing that not many other services like this have, a password generator. It can create a password on your behalf. You don't have to remember it. It will use it for you once you log into whatever it is you're logging into. So it can set up some passwords that no one would have a prayer of guessing. Now, as a Space Nuts listener, we are once again offering you 70% off. Get up to 70% off on a 2-year plan. They'll give you 1 month free. That's on the premium plan as a Space Nuts listener. There's a special URL so you can take advantage of NordPass. It is nordpass.com/spacenuts. nordpass.com/spacenuts. Check it out today. If you want to secure your passwords, make them easier to manage and easier to access, and don't have to think about trying to remember them, NordPass is for you. nordpass.com/spacenuts. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, if you've ever thought about becoming a patron of Space Nuts, you can do that by visiting our website, spacenutspodcast.com, and click on the supporter tab. As a patron, there are benefits, and you get a commercial-free version of the podcast. You also are supporting the podcast and keeping us very much alive and making up the losses on Fred's book, by the way. And it's very much worthwhile. It's not mandatory. I would never go down that road. I don't think that would be proper. But it is voluntary, and it was an idea that came from the Space Nuts audience. They wanted to contribute to the show, and so that's how Patreon came about. You can also do it through Supercast or PayPal, however you like. Slip some cash into my letterbox. I'm okay with that. But yes, if you want to become a patron, all the details are on our website. So check it out if you so desire. Now, Fred, from one radio telescope to, I'm guessing, what would probably be an optical telescope of some kind that they think would be better suited out past Saturn. This is a bit of a different type of slant on sending a telescope into space. Of course, we've got Hubble. We're soon to have James Webb. But now the thinking is, look, we could probably get better results going out past Saturn, sticking one there. Why are we thinking that?
It's an idea of an individual scientist who's written about it. I'm afraid we're plugging the conversation platform today. And
they deserve to be plugged.
They do,
the conversation website is excellent.
It's fantastic. That's right. So this has come from Michael Zemkov. I hope I'm pronouncing his name correctly, who's an associate professor of physics at Rochester Institute of Technology in the United States, of course. And what he's proposing is a small telescope with a lens perhaps 6 inches, 150 millimeters in diameter, but put it on a spacecraft and whiz it out to place it in orbit beyond the orbit of Saturn. Why would you want to do that?
Good question.
Yeah. So you're sending it a billion miles, 1.5 billion kilometers from the sun and the inner planets. And the reason why that's a good thing to do is because you get an outside view of the inner solar system. And that's something that we haven't had before. Apart from things like Voyager 1, I think it was, doing the look back to the small blue dot, things of that sort. But the view from the outside of the solar system could be extremely instructive because you're looking at, first of all, the dusty disk around the solar system. The solar system's a very dusty place. It was formed from this swirling mass of dust and gas in which the planets themselves formed. And there's still a fossil of that. The last vestiges of that protoplanetary disk still exist in the shape of the dust around the inner solar system. And you probably are aware that we can actually see that with the naked eye. It's something called the zodiacal light, which is in your skies out there in central western New South Wales, up there in Dubbo, are perfect for seeing the zodiacal light, Andrew, because I used to see it very often when I was at Coonabarabran, not very far from you, when I was working at the observatory. What it is this pillar of light that is basically sticks up above the horizon after the sun has gone down and after twilight has ended. In the direction of the sun, say at sunset, you can see this pillar of light stretching upwards. Excuse me, which is aligned with the ecliptic. It's aligned with the path of the plane of the planets in the sky. And what you're seeing there is the dust in the planetary plane being lit up by the light of the sun, which is now below the horizon. You can see the same thing before dawn as well if you're an early riser. Really very faint.
I'll have to pay more attention.
Yeah, if you're up, you are up before dawn at times, aren't you? In winter time, it would be worth having a look. Look to the east before the sun's coming up, and see if you can find this pillar of light. The zodiacal light, because it lies along the zodiac, essentially, which is the ecliptic where the planets travel in the sky. So imagine being able to study that. Actually, I'm just going to throw in one more piece of trivia about the zodiacal light. It's what Brian May did his PhD on. There you go.
Oh, is that right?
Yeah, from Queen. Yeah.
Wow.
So that's just throwing that in. But imagine looking at that from where Saturn, beyond Saturn, from the depths of the solar system, or beyond the orbit of Saturn. Let's be technically correct about this. Then you're going to see the whole inner solar system and be able to investigate the distribution of this dust. Now, there is something has happened this year, actually, which kind of underlines how important that is. And it is, I can't remember whether we talked about this or not. Excuse me, Andrew, I've got to clear my throat. It's the mid-morning frog in the throat. I do beg your pardon. Yeah. I always get it at this time of the day.
Zodiacal throat.
The zodiacal throat, that's right. I need one of those zodiac cubes to clear it off. New Horizons, the spacecraft that flew by Mercury in 2015, a NASA spacecraft, that was used to revise the total number of galaxies in the observable universe, because it carries cameras on board. And what they did was they looked deep into space with these cameras and could do a revised count of the galaxies that could be seen down to a certain level. And it turns out that the same calculation done by the Hubble Space Telescope, which is where our best guess as to the number of galaxies in the observable universe comes from, that is looking at the sky in the inner solar system. So it's always looking through this veil of dust of the zodiacal light. And the best knowledge, the best appreciation, or the best understanding we had of the total number of galaxies in the universe back in 2017, I think, which came from the Hubble telescope, it was 2 trillion. But the view from the New Horizons telescope, way beyond Pluto, with its clearer view of the sky, actually meant that was revised downwards. It's now 200 billion. A factor of 10 lower. And it's because New Horizons is not looking through this dusty veil that there is in the solar system. So that's one of the really good reasons for sending the spacecraft out to look back at the inner solar system from beyond the orbit of Saturn. But there is another one, and that is that if you do that, you can also use the sun as a telescope because of its gravitational lensing effect. Yeah, so you can get well away from the sun. You basically obstruct its direct light and look at the Einstein rings that form around it because of its gravitational lensing effect. And by looking at those and analysing them, you can actually see objects that you certainly would not be able to see with such a small telescope. So it's a possibility that might actually allow, for example, in fact, the author talks about the possibility of mapping planets in other star systems. That is an extraordinary thing to envisage, but with using the sun as a gravitational lens and forming an image at this telescope, you never know. That might be a possibility.
Yeah, quite incredible. And he's talking about piggybacking it on some other mission.
That's right, yeah.
Yeah, that could be a big advantage. It seems to be the way to go. You work out a mission-specific situation and target, and then you think, well, what else can we tack onto this thing and take advantage of the mission, like they did with the helicopter on Mars.
Exactly.
So, Yeah, I hope this one happens. It sounds like there's all sorts of good reasons to do it and some pretty great thinking. So if you'd like to read about that particular story or the Parkes Radio Telescope, we highly recommend theconversation.com website. Lots of fabulous articles there that are well worth reading and well researched and well told. Probably one of the best journalistic websites around, I would venture to say. This is Space Nuts. Thanks for your company, Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
I think I just said that.
I think you did too.
Before our segments, I always count in reverse, and that's exactly what. Yeah, I didn't need to do it. Now, at the risk of embarrassing Fred, he just went to check on his wife, and it turned out to be the sulphur-crested cockatoos or galahs instead. So it's pretty insulting, Fred. I'm sorry to say.
No, I could just hear this noise outside. I knew she was away, and she'll be back soon.
These birds sound like.
They were actually they don't when they're kind of saying you got any bread, mate, or anything like that. It's a much gentler tone.
Yes, it is a much gentler sound. It reminds me of another Instagram page that I follow called Peggy and Molly, and it's about a dog and a magpie that have become the best of friends, and the magpie can bark. It's really quite extraordinary.
They're amazing birds as well.
If you're on Instagram, look it up, Peggy and Molly. It's worth it. It's just so much fun, that page. But we've got questions to answer, Fred, here on Space Nuts. So let's go to our first victim, and it is Jim.
Hi, this is Jim from Clarksville, Tennessee, and I had a question about E equals mc squared. I know the M stands for mass, but I understand that it's resting mass. And how can mass be resting? Because everything's moving. And if that's the case, wouldn't mass be momentum? So E equals pc squared? Love your show and love you guys so much. You're just wonderful. Thank you.
Oh, that's nice. Thank you, Jim. I'll give you an example of mass that's not moving. It's copies of Space Warp on the bookshelves.
Certainly not moving at relativistic speed.
No, definitely not. But also kudos to Jim for challenging one of the greatest scientists in history.
Yeah, no, it's a great question, actually, and it's one we haven't tackled before. It's actually the term is rest mass, not resting mass, but you got the idea. It's also sometimes called invariant mass, and it is the mass of a particle when it's at rest. In other words, it's not moving. Now, Jim's absolutely right. Everything is moving, and special relativity tells us that as things move, their mass increases as they get nearer to the speed of light. It's one of the bizarre consequences of special relativity. And that's why when you're talking about the mass of a particle, you need to specify its rest mass. But by the same token, because of that mass energy equivalence, rest mass is also equivalent to rest energy, which is the energy a particle's got when it is not moving, so so the equation works no matter what speed you're going at. You don't need to build in the momentum because if you've got this particle that's traveling at close to the speed of light, E equals mc squared gives you its relativistic mass, the mass it's got. Sorry, the relativistic energy content. In other words, the energy content it has. Taking into account its movement, so the mass of the particle and its movement. It's a very, very good question, and I always think it's one of the most bizarre things that as things travel nearer the speed of light, they get more massive. It's very odd.
Yeah, indeed. All right. Wasn't that difficult to answer after all, Fred?
Well, it depends whether that was an answer that people think is any good.
I'm sure
Excuse me.
Jim is adequately satisfied.
I hope so. Thanks, Jim.
Let's and thank you, Jim, for your question. Let's move on to a question from Damien. I don't think we've had a question about this before either.
Damien here on the Goldie, basking in the sunshine, watching the waves, pondering. Dark matter. I find it interesting that we have a handful of dark matter in our solar system when it's 27% of the total, and that all the normal matter is 5%. Please explain, in my best Pauline Hanson whiny voice, how do you have something that's 25 times the amount, but in our solar system, it's only a handful? Are there other solar systems that have more dark matter than all the normal matter? Where are they? Is Alpha Centauri?
Thank you, Damien. What is this dark matter of which he speaks, Fred?
I wish I knew.
Look, it seems to have taken over from black holes as the most asked question in our show, and that's not surprising because it's such a mysterious thing. But I'm not sure that the numbers stacked up. I was doing the math in my head while he was talking.
No, that's right.
Yeah,
not quite. So, what do we know about dark matter? We know it is something that does not interact with normal matter in any other way except that it has gravity, and that's how it's been revealed by its gravitational attraction on galaxies to hold them together when they should be flying apart. That's how we know it's there. It's one of the reasons why we know it's there. But the proportions are a little bit. You kind of got to be a bit careful. So these numbers come from basically looking at the universe as a whole. We do these gigantic galaxy surveys that show you how mass is distributed in the universe and how it's affected, gravitation affects it. And you can work out these overall statistics. And was it Damien? Was that the call?
Yes.
Yeah. So as Damien mentioned, sorry, Damien, too much going on.
He's from that horrible, decrepit part of the world.
Yeah. Anyway, that's all right. The approximate distribution of stuff in the universe is 5% normal matter, as you said, something like 25 to 27% dark matter, and something like 75%. Something like it's actually they don't stack up. I've forgotten the exact number. Yes, about 70%. That's right. 70% is dark energy, which we really don't understand, and energy of space itself. Roughly 25% dark matter and roughly 5% normal matter, which is mostly hydrogen. Basically, all of it's hydrogen. The rest is just the rest of the stuff is a tiny fraction. So that's the sort of average over the whole universe, and we know that dark matter clumps where normal matter is. So where normal matter clumps, dark matter clumps too. That's the way to put it. So galaxies are richer in dark matter. But the proportions are probably about the same in terms of the ratio of normal to dark matter. And so that exists in the solar system, in the system of Alpha Centauri, in systems probably at the other side of the galaxy. Those proportions would remain. The reason why we don't kind of detect it in the solar system is because we think that dark matter clumps on much larger scales than the scale of a galaxy. So that, if you're looking within a galaxy, it's mostly fairly uniform. Some astronomers have suggested that it might not be that uniform, that there might be clumps within galaxies too, but that the smallest clump would be of the order of 1,000 light years. And that still means that if you've got a solar system, a planetary system, that scale is much, much bigger than the scale of a planetary system. So to all intents and purposes, we live in a dark matter field which is uniform. And that's why you don't find the sun pulling stronger in the direction that you think it would be, because there's more dark matter there. It's effectively uniform, so you don't detect it.
Right. Well, that would that be a clue as to how to figure out what this stuff actually is? specifically?
Yes, it is, because it tells you a lot about it. For example, the fact that we don't see a lot of gravitational lensing going on when we look out to distant stars tells you that it's not something like orphan planets or black holes or normal matter that's sort of some kind of debris that's dark and invisible. It's not that. And the observations I mentioned before tell you that it's got to be something much more exotic than that. And the best guess is this species of subatomic particle. We don't know what it is. People have theorized that it might be something called an axion or a neutralino, but we really don't have any observational evidence to support that yet. All we know is that it's there.
Yeah, gosh. All right, Damien, can't answer your question beyond what we already know, which is the percentages and the clumping effects. But thanks for getting in touch with us. Lovely to hear from you, and hope you're suffering your jocks on the Gold Coast. Now, let's move on to our final quiz. We're going to do 3 today. Actually, we're going to do 4 because Robert's got a double bunger.
Yep.
Good day, Mr. Dunkley and Professor Watson. This is Robert from Reading, Pennsylvania in the U.S. I had a question about Mercury. Being as it has a strange orbit, they say, and is missing quite a bit of the crust from the planet, I was wondering if maybe that was the planet that struck the Earth in the early days, and that's how the moon got here. I'd like to hear your thoughts on that. And also, with the advances of the telescopes that we have, and they keep getting better, I was wondering if you think that maybe someday they would be able to detect light on a planet, as our planet is lit up at night. Maybe if we could detect that, that would suggest intelligent life. But being that probably there was no dinosaurs on that planet, so there would be no petroleum probably, what do you think the technology would be there to detect for industry? So like if they were wind power or solar power, how would you detect that? And what would you look for? Well, that's about all I have right now. I have a million other questions that I could ask, but I'll save it for now. Thank you very much. Enjoy the podcast, and I look forward to hearing your responses. Thank you very much.
Thank you, Robert. Great questions. We'll start off with, could Mercury have hit Earth and created the moon?
Something did hit Mercury, we think. Mercury's orbit is not that peculiar. I think for it to have been the object that did hit Earth and created the moon, it would have had a much stranger orbit than the one it's got. That object is something we call Theia. It's a theorized theorized object, but astronomers are confident enough in it that they've given it a name. Theia, the mother of the moon in Greek mythology, I think. Very nice idea. But Theia was probably smaller as well. It had to hit the Earth hard enough that it would create a cloud of Earth-like material that then would coalesce into the moon without contaminating it with its own material, if you see what I mean. Because we know that what the moon is made of is much the same as what the Earth is made of, and not what something else is made of, including Mercury. So it seems unlikely that it was the planet Mercury. But Mercury is thought to have suffered something large hitting it in the early history of the solar system, because it has a core, an iron core that is big and is really more fitting to a planet the size of the Earth or Venus. But it's not. It's got a mantle around the core which is very thin, and the suggestion is that an early collision knocked most of that mantle off, and so Mercury has forever been a smaller planet than it should have been. It's got a big heart, if I can put it that way, but only a small mantle.
Yeah. His question prompts a thought in my mind that brings us back to the Theia collision. What if that hadn't happened and the moon wasn't thus created? Would we exist?
Maybe not, because the moon's had a number of effects on the Earth. One is stabilizing the Earth's axis of rotation so that it doesn't wobble about too much. It acts almost like a flywheel. Compared with Mars, which has shown evidence of changes in its axis of 10 or 20 degrees over quite short timescales. If you've got an evolving population of living organisms, the last thing you want is gigantic seasonal changes, which you get over that sort of thing. And the other is...
We're managing to create them for ourselves.
Indeed we are. But the other thing is the tides probably might be what actually allowed primitive animal life to get from the oceans to the land, because you've got this region where you've got both water when the tide's in and land when the tide's out, and that's a kind of transitory region that might have allowed sea creatures to become land creatures and to generate humans rather than things like highly intelligent whales.
And how much bigger would Earth be if the moon wasn't created?
Don't know. A bit bigger, probably.
A bit bigger.
Yeah. When you think the moon has an 80th of the mass of the Earth, that's the fraction. So, you might, naively, you might just say, well, add 1/80th of the Earth's mass to its present mass. That means it's grown by a little bit, or it would have been a little bit more than 1% bigger in terms of its mass.
Okay. Thank you, Damien. Robert. We're halfway through Robert's question. So Mercury hit Earth. The next part of his question was about the advancements in telescopes and whether or not we'd be able to look at exoplanets and see whether or not artificial light was coming from them created by other civilizations, and how could we detect that? I love that question.
Yeah, it certainly is a very appealing idea and has been obviously thought about many times, but you've got to kind of look in the case of the Earth, it's only when you're in orbit a couple of thousand kilometers above the Earth's surface that you actually see these lights. You get to interstellar distances, they fade into insignificance. They're just tiny pinpricks, and especially if you're trying to observe planets against the glare of their parent star. The lights are really very, very small. On the other hand, if the telescope beyond Saturn that we were just talking about a few minutes ago materialized, and you could use the sun as a gravitational lens, maybe you get enough magnification on that to spot the light of spot the continents of an exoplanet. I still doubt you'd see the lights, though. But it's clearly something that is in the back of people's minds, that if you found unusual light coming from a planet, maybe you should think about intelligent species. The other half of Robert's question is really interesting, though, because if you've got a planet where there is no fossil fuel, and so they're not putting sulfur dioxide and things of that sort into the atmosphere, which you might be able to detect by spectroscopy. If you're relying entirely on solar or wind power, what have you got to show that there is a techno civilization there? Not much is the answer. And the same is true, I kind of mentioned this in Space Warp, that there might be intelligent civilizations that we could never detect. Another would be if, just going back to what we were saying a few minutes ago, if we hadn't evolved as land creatures, if we were on a water world, which was entirely surrounded by ocean, we'd evolved underwater, there might not have been much awareness in that body of water of things going on outside. And it may be that there would be no signals of any kind that would reveal that there was a technological species in existence underneath the ocean. Interesting question.
Look, there's all sorts of weird possibilities, I suppose. And yes, and you got to think about the possibility there may be prehistoric civilization. So, they've only just invented fire, so got no hope of finding them.
That's right.
And the other issue with the detection of artificially created light is the time factor. I mean, the light travels at a maximum speed over a vast distance, there's every probability that our light hasn't travelled very far since we first started creating artificial light in the scheme of things. So other civilizations probably, even if you could detect it, it wouldn't have reached them yet.
Maybe not. That's right. Yep. That's always the issue that when you're searching for the needle in the haystack of to find alien civilizations, it's not just a needle in a haystack of space, it's a needle in a haystack of time as well, because we don't know how long civilizations last.
Exactly. That's the other issue. Yeah. There's every chance that people may detect our civilization's activities
after we've gone,
and we won't be around by the time they come to say hello.
Could be.
All right. Thank you, Robert. Great questions. Thank you, Damien. And thank you, Jim. Jim, I was going to come and visit you, but I missed the last train to Clarksville. Sorry about that.
Okay.
And by the way, if you do have questions for us, don't forget to visit our website and send us your email, which you can do on the AMA tab, or you can click on the recorder option and send us a voice question. Don't forget to tell us who you are or where you're from. We love to know these things so I can tell lame jokes. But that's the best place to go. And there's also a send us your voice message tab on the right-hand side of the website. And while you're there, don't forget to visit the Space Nuts shop, because there are all sorts of things to see. A few people have told us, I'm going to buy some merch. I really want to get some Space Nuts merch. Over my shoulder, you can see the Space Nuts tote bag hanging on my door. Just there somewhere.
Got it.
Space Nuts mug.
Yeah.
Oh, no, that's my golf trophy. But you know what I'm saying? And there's the Space Nuts shirt. See? So, and that's just a few things. Flip-flops, there's all sorts of other bits and bobs in the Space Nuts shop on our website, spacenutspodcast.com. So check it out. And, Christmas is coming up and there are people that are very hard to buy for. You might just find something perfect for them on our website. That's where we leave it for another week. Fred, thank you so much. It's been a pleasure.
Great to talk again, Andrew, as always, and I look forward to sharing the merchandise with you next week.
Indeed. Fred Watson, we'll let him spacewalk his way into the rest of the week, and we'll catch him on the next episode of Space Nuts. Thanks for your company. From me, Andrew Dunkley, it's bye-bye. We'll catch you next time. See ya.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.